All right, this morning I'd like to go over rotational motion. This is a very simple concept, at least as far as we're going to take it. We can go a lot more in depth, but for the sake of this class, we're keeping rotational motion pretty simple. Okay. What we have here is, so far we've talked about what happens if you go in a straight line, either directed to the side, or you go up, or you go down. We've also talked about what happens when you go in a parabola, so like a projectile. Okay. What we're going to talk about now is what happens if you go in a circle. That doesn't look like a circle, but we're going to go with it. The idea is, remember a vector. Vectors are based off of magnitude and the direction. When we talk about these two here, when we talked about velocity changing, we were always referring to the velocity changing its magnitude. When we talk about the motion of an object, though, in regards to a circle, then we're talking about, now you can change your magnitude when you go in a circle. Imagine going around a roundabout and slowing down while you go around. Your speedometer value changed. But as you go around in a circle, you're also continually changing your direction. And so that's what creates kind of this different problem. So let's imagine on this circle, I've got some object. And it's got what we call a tangential velocity. All right. Now this tangential velocity, and as we continue going around, this is the velocity that exists at any instantaneous moment. A good way to think about this is, like in class, I swing my lanyard with my keys around a lot. If I was to just let go of the lanyard, all of a sudden my keys would fly off at some velocity in some direction. That velocity they'd fly off with, that would be that tangential velocity. Now, since we have a change in velocity, that means that we are also going to get an acceleration. So, we call this acceleration centripetal acceleration. A centripetal acceleration is equal, we'll go like AC is equal to V squared over R. All right, now this V, this is our tangential or linear speed. And this is the radius of the circle. All right. Now, since we have acceleration, it's easy for us to see, well, we can also get a force then. Because force is equal to mass times acceleration, right? So if we were to plug this into here, my centripetal force equation becomes mass times velocity squared divided by R. Because that's a real nice equation. All right. Now, in this case, centripetal force is always going to point inward. It's always going to point towards the inside of our circle. All right. Now, centripetal force isn't like a force of nature. It's a title that we attach to other forces. All right. So let's say, for example, in this circle, let's say that the object was my keys. All right. And so we'll draw a little line here to attach it. So that line, that's my lanyard. All right. As I swing it around, this lanyard is under tension. That tension is that's the force that's drawing the keys back into the circle. And so in this case, we would consider the tension, which is kind of a natural force. The tension would be considered a centripetal force. Right. Another good example is, let's say you have have an ellipse, okay, and we've got the sun right here, okay, and you got, all right, the Earth over here, and it travels around, okay, and it's cruising, woo, and it's got its tangential velocities and so forth, okay. Now there's no string holding this in place, but we do have the pull of gravity that's constantly pulling on the Earth, keeping it in this shape. Okay, and this is pretty exaggerated. All right, and so in this case, that pull of gravity is the centripetal force. Okay, so gravity is what keeps us in orbit, okay, revolving around the sun, but we're going to label it as a centripetal force. Okay? So any of the forces we've talked about in class can be considered that. Now, let's just do a simple problem. Right? Let's say that, let's do one from your homework actually. Okay, problem 8. All right? This one's, you got Jimmy Swanson, he's at Sand Hollow Reservoir, and he's tubing, all right? And so the line of the rope is 15 meters long. Let's draw a boat. Sail on it. Okay, and the boat, give it a little water, and the boat has that line and it's 15 meters. Okay, and let's see, he has a mass and he's out here. Woo, Jimmy. Okay, and he has a mass of 85 kilograms. All right. Now, we know by the problem that the tension in this line right here, that tension is 200 newtons. And we just want to know how fast he's going. Okay? Now, we assume, okay, in this case that he is being like swung out to the side. All right? So, let's look at this. My equation is mv squared over r. We want to solve for v. So let's just solve for v first. I'm going to take the r times it to the other side. Okay. I'm going to divide by m. So I'm going to get v squared is equal to rfc over m. And then I'm going to do the square root to both sides. So v is equal to the square root of rfc over m. So I'm going to plug in my values, square root of r. Now my r is 15. Now some people are like, well, wait, radius is half the diameter, right? Well, in this case, this is the radius, because if he was to continue going in an entire circle, then his diameter would actually be 30 meters, okay, with a radius of 15, all right? The centripetal force is that 200 newtons. And we have our mass of 85 kilograms. This is meters. Okay, we take that, plug it into our calculator, we're going to get something along the lines of 5.9 meters per second. Okay, now the next part of the problem is like, well, how does your velocity change if you double, okay, the length of the line to 30 meters? And so you just redo your equation. Okay, so here's our equation again, and we're going to redo it at 30 meters. 200 newtons at 85 kilograms, and you get a value of 8.4 meters per second. All right, and it's really that simple. Okay, we're not going to go any more complex than this. If you take like the AP test or you go into college physics, they'd go more in depth. And we'd use these in kinematic equations and so forth, but we're not going to deal with that in this class, just because the standards don't require that, and we focus on other things. But hopefully this makes sense. If you have any questions, please come in. Love to go over some examples with you. The homework shouldn't be too hard. If you have any issues, then let me know.